So today, I wanted to make sure that you guys, this is not a bad day. If you've noticed, volume seems really easy after surface area and lateral area, right? But you still have to know your formulas, because a heads up on what the test could be entailed, okay? I'll tell you right now, in my advanced classes, this is what the test would look like. You would literally be given a diagram, and I'll say lateral area, surface area, volume. Give me all three. And just from one diagram. Or, you know, obviously you have work backwards problems that can do volume, then you actually can find the surface area based off of that, or so on. Also, don't forget you have to know your right triangles. Pythagorean Theorem, you know, 30, 60, 90, 45, 45, 90, all those type of things could be used. So I asked you before I started recording to see if you knew the formulas. So I want to know the surface area of pyramids. Now guys, here's an easy way of memorizing this. What are the lateral faces of pyramids? It's a triangle shape, right? So if that's the case, you're going to have your 1/2 in there, right? So it's going to be 1/2 what? All right, perimeter of the base times slant height plus how many bases does a pyramid have? So it's just one, so 1b, so the area of the base. So that's kind of, talk yourself through what the shape looks like in your head, and you can probably get a lot of this down. All right, now prisms have how many bases, guys? 2, and what are the lateral face shapes have to be? The lateral faces have to be rectangles for a right prism, correct? Now, so we know they had to be parallelograms if nothing else. Well, doesn't this kind of look like the area of a parallelogram, right? The perimeter of the base times the height, that's not what it is. Well, actually it is an area of a parallelogram. But it's when we put all the sides together to make a giant one. But that's all it is, perimeter of the base times the height. But again, how many bases do you have? 2. All right, now volume, this is what's so easy about prisms. Because of Cavalari's principle, we know they can be oblique or right. But what's the volume of it? Area of the base times what? Times height. Very basic, very simple. All right, cylinders. Notice I put that right below, excuse me, not above. Gotta make my directions right today. Right below prisms. So let's put in what we know that would replace everything for prisms. Instead of perimeter, what do you put down? Circumference, right? So we have circumference, so we get 2 pi r, and then the height stayed the same, so we get 2 pi r times the height, so basically circumference times the height. Again, how many bases does a cylinder have? 2, but what are they? Circles, right? So the area is pi r squared. So I could basically use a prism one to tell me what a cylinder one is by just adapting it to our circles. Well, the volume is the same idea. I really don't want area of the base times the height for this, because what's the base always for a cylinder? A circle. So it's going to be pi r squared times the height. All right, cones. Again, cones, this is the one that's unique to memorize, but honestly, if you had to derive it, you could. But remember, it's really just a pyramid. Instead of going 1/2 the perimeter, you go 1/2 the circumference. And as a result, you end up getting pi times the radius times the slant height. That would be the lateral area part. But again, how many bases does it have? What's its shape, though? So it'd be pi r squared. So today, we're going to add the other 2 volumes on. So we're going to work with those. Now, unfortunately, I don't have all my cool stuff that I used to. Ooh, I think I can give the example. You're not going to be able to see it on the video, but that's okay. All right. Now, I need some people in the front-ish rows to work with me on this. Do you guys agree with me that this pyramid and this prism have the exact same height? Are you guys with me on that? All right. Gender. Do they have the exact same base? All right. Now, obviously, looking at them, which one's going to have the bigger volume? The prism's going to have it, okay? But how much? Let's have a little bit of fun. Let's find out. Now, this is messy, but it's carpet. Don't tell Mr. Holtrap I'm getting water on it. All right, so we're going to put water in there. So, oh, beautiful. That actually is better than normal. All right. Everyone with me on this? Okay, I'm going to pour it in here. How much of that did it fill? About a third? It's not half, right? I'm giving it over to Lindsay, you can see. She told me it was half. All right. It's about, you guys see it? It's a third. So I could do this again. How many other times? 2 more times, and it'll be the same thing. So think about how I can calculate volume. If I know the area of the prism, what would I have to divide it by? Because how much did the pyramid give me? 1/3. So basically, can I say I multiply it by 1/3, or could I say divide by 3? Yeah, so basically that's how easy it is. It's really the same thing as we had with a prism, except for it's just 1/3 of it. Because again, you get to see how it filled it in perfectly, 1/3. So that's what it is. It says the volume of a pyramid with a base area B and a height H is just the following. Volume is area of the base times the height all over 3, or again, if you have fractions, you could go 1/3 area of the base times the height. Either one of those work. Here's the thing I'm going to give you as a hint. If it goes to a point, it's the 1/3 ones. So again, though, here's what you need to remember to do. Oh, Cavalari's principle, by the way, still holds true. I don't have to be regular pyramids anymore. I just need to make sure the cross sections are all the same. So with this, draw your what? Draw your base. And what I mean by base, I mean the base polygon. Some of you need to learn to draw your base better, so you're more accurate with what you're calculating stuff on here. But it says draw your base. But here's the other thing you need to remember with this. If you have a regular pyramid, remember your apothem, your height, and your slant height all make what type of triangle? A right triangle. Might be something you need to know. All right? Also, when you work with lateral edges and stuff, that might be a point that we need to know. All right, let's have some fun, because this isn't going to be that hard. It says, so find the volume of a square pyramid with a base edge length 9 centimeters and a height 14 centimeters. Notice I didn't have to be regular because I already have everything I need. What am I going to draw? Yeah, we're going to draw our base. So we have our base, even though I love the squares because they're the easiest ones to draw. All right, I'm looking for this. The volume is area of the base times the height over 3. So I don't have to worry about perimeter this time. I just need the area of the base. What formula are we going to use for the area of the base, guys? Side squared, okay. So we get 9 squared, which equals 81. All right, and so I know that's going to be the area of the base, so I put it in my formula. I'm still trying to figure out how to teach you guys to write a formula down and put the work directly below it. Now, some of you are like, Gregerson, what are you talking about? No, seriously, on quizzes, it was really hard to find formulas sometimes because some people would write their formulas way off to the left, but their work was somewhere way off to the right or bottom right or something. Like, I was like, that's not plugging it right below. So can we just try this, please, to help me out here? Put your area of your base in, which is 81. What's the height going to be for the, they're basically saying the height is here, 14 all over 3. Now, here's how you know you're not going to have a fraction. If that 3 can divide into either one of those numbers on top, we're good. So what do we got, my friends? Times, what'd you get? Yep, that's what I've got too. So it'll be 378. How is this going to be labeled? Okay, guys, this only happened on one person's quiz yesterday, but I felt so bad for them. Every lateral area and surface area, guess what they labeled it? I'm like, oh, you know, we just did volume the day before. I was just like, devastated from them. They lost 2 points, so it's not like they lost like all their work and, you know, the formulas, whatever. It was like every label, because it totally miscommunicated what they wanted, right? I was just like devastated for the person. All right, next one. Oh, look at the fun of this. It says, find the volume of a regular hexagonal pyramid with a height equal to the apothem of the base. This is still a struggle for some people to do. All right, so with this, what are you going to draw? You're going to draw the base. And I'm going to draw it fairly big because I feel like this is one that you guys, some of you are starting to really get really good with hexagons, and some of you, well, we need to improve a little bit on this. All right, so with it, I need to know my apothem. I don't know it. But I do know that all the sides of this, because they told me it was a regular hexagonal pyramid, so I knew it was a regular polygon for the base. My formula for the regular polygon area of the base is going to be apothem times perimeter over 2. So what do I need to find? The apothem and what else? And I need to find the perimeter. Well, can I find the perimeter pretty quickly? Yeah, the perimeter is just 6 times 12. So I know that's 72. So that we got taken care of. But the apothem, what do I need to draw in? Yeah, my central angle triangle. By now, I'm hoping that everyone remembers the central angle is 360 divided by 6. That's 60 degrees. But your apothem does what to the central angle? Bisects it. So we got a 30, 60, 90. But also the apothem bisects the side. So this is 6. That's the short leg. The apothem is which leg on a hexagon here? It's the long leg, right? On an equilateral triangle, it's not the same thing, people. A lot of you kind of got fooled that way. So this is going to be 6 root 3. So all I have to do is plug it in. 6 root 3, make sure you got the perimeter correct. That's going to be 72 all over 2. So whatever 36 times 6 is. Did you guys get 216? So I get here, if I can get my equal signs, so 216 root 3. Now that's the area of the base. I'm looking for the volume. Well, let's write it down. The volume equals area of the base times the height all over 3. So the area of base, 216 root 3. What's our height of this? What did they tell us? The same as your what? Apothem. So the height is equal to apothem, so that's going to be 6 root 3. So I get 6 root 3 all over 2. All right, excuse me, over 2. Hello, people. What should that be? 3. All right, here's how easy this is to simplify. Guys, what's root 3 times root 3? So is that true? Because root 3 times root 3 is 3. Divide by 3. That became 1. Now all I have to do is take 216 times 6. 1,000 what? Yeah, 1,000. I don't know why it wants to do that. Hello. 1,296. What's going to be my label? Cubic feet. So there's your volume. All right, guys, what do you think so far? It's not bad, is it? Now, this one's kind of goofy because you have to be very careful with how it's worded. But on the next one, it says, find the volume of a regular hexagonal pyramid with a base edge length of 2 centimeters and a height equal to the area of the base. Now, height is 1 dimension and area is 2 dimension. So what do they mean by height is equal to the base? The number, right? They're not talking about squared and not squared is not the same thing. But it's the idea that you literally just going to plug in the numbers for it is how it's going to work. But again, notice why I picked this one. What type of pyramid is this again? It's a hexagon. Guys, what's the number one people need to work on? Hexagon. It's not even if it's a prism or a pyramid. You just got to know it. So the first thing you're going to do, because you're wise like this by now, is draw a base. A lot of you need to go back to your comments on your homeworks, especially your class, because I always grade it first, so you always get you get more comments and better comments probably than any of my other classes, right? Like, here's the thing. I will comment on there. Where's your bases? Where's your formulas on this? Yes, ma'am.
Oh, some of the notes have this random
I can't do anything about that. Just go with it.
I know, I'm just
Yeah, halfway through. Go ahead and just grab some new ones if you want. It literally halfway through, it started. This is the weirdest thing about the copy machine. I'll tell you this. So with this one, guys, don't we have to do the same routine as we did on the very last problem? Don't we need to know what the apothem is? Don't we need to draw our central angle? Yeah, triangle. All of that stuff is true, but here's the numbers are nice, okay? The apothem bisects the side. It goes from 2 to what? 1. So what's the length of your apothem? I mean, so it's one of the smaller ones we've had in a long time. The perimeter of the base, 6 times 2, people, what do you get? 12. Area of the base, apothem times perimeter over 2. So that's root 3 times 12 over 2. What do we give for a value there? 6 root 3. So that means my height is also what? 6 root 3, because it says the height is equal to the area of the base. So the volume, the formula stays the same. What's your area of your base? 6 root 3. What's the height? All over 3. I about put 2 again. I have to be careful. All over 3. So guys, what ends up being the value? 36. So that's 36 cubic centimeters. Again, just multi-step process, but if you follow the rules. Another thing I look for, I look to see if you write your area formulas down every single time you use it. Guys, this one is commonly messed up. A lot of people forget to divide by 2 for the area of the base, okay? Volume, not such a big deal, but make sure you always write your formulas down. What do you think? Pretty easy, isn't it? All right, well, now we're gonna do volume of cones. Now, unfortunately, I don't have any cool cones. But the relationship with cones and cylinders is exactly the same relationship that we had with the pyramid and the prisms. All right, so I want you to think about this for a moment. Have you ever gone to like a fair or like a trade show or something with your parents where they're giving away free water? What is the shape of the cups? Cones, because you only use a third of the water then. Because if you had a regular cylinder cup, it uses 3 times as much. So the next time you ever have that, stand there and get 3 drinks. Make it equal. They're just being cheapskates. They're really brilliant, really. You still get a sample, but you don't get as much. That's why they use cone cups. I know. Doesn't that like bring your refillable water? I'm just telling you, we'll have your water bottle there. True? All right. So guys, next week we are going to go out to the atrium and we're going to calculate the volume of the atrium based off of our formulas. I will try to have basic stuff figured out, but we're going to estimate the volume of the atrium. Are you guys ready for it? So make sure you know your formulas, otherwise that would be, and you should be able to do it within like 15 to 20 minutes at most. So I'm hoping that's our goal to do after your test a little bit. We have to see where we get with homework and things on next week. All right? It's kind of cool. All right, so volume of cones. All right, guys, talk to me. What was the volume of a cylinder? What was the volume of a cylinder? Volume of a cylinder was what?
Oh, wait. Pi r.
Pi r squared times what? Height. But we said a cone is a third of that, so what's this one going to be?
Over 3.
Yep, so it's going to be pi r squared times the height all over 3. Just remember those little cone glasses, like paper glass cups. They just don't get enough water that way. All right, so scholars, let's just go for it. Why take the time not to do it? We know how to work with formulas by now. On the next one says the volume of a cone with a radius 7 centimeters and a height of 15 centimeters. Do I need to worry about the slant height right now? No, slant height is what I need for lateral area and surface area. This is for height. But if you're a person who needs to see the visual, remember cones are the easiest ones to draw. There's your cone. Earth-shattering when you do that. So then you have your radius is going to be 7, your height is going to be 15. Because if you can draw that, could you see the right triangle? If you had to find the slant height, could you? Yeah. So let's just plug and chug it down though. We have the volume is pi times the radius squared times the height over 3. Now, could I, if I know there's fractions, can I go 1/3 times all of that instead of divide by 3? Yeah, so do that if you see fractions. So when we do this, we get pi. My radius is 7 squared. Your height is 15 all over 3. Now, here's again, how do I know if this is going to have a fraction for an answer or not? If 3 can divide into either one of your radius or your height, you're okay. It's not going to be a fraction. So what do we get here? 7 squared, basically times what number? Times 15, right? Divided by 3. Or you can go 7 squared times 5, which is the same thing. And what do you guys get? 200 and what? All right, what do you cannot forget? Pi, right? And this would be in cubic centimeters, but what does the direction said to? And what? And to the nearest tenth. So I have to do an and here. So my volume is exact, and then we get our 245 times pi. Use your pi button. What did you guys get to the nearest tenth? 169.7 cubic centimeters. Both of those are required. What do you guys think? Hard, easy? It's not bad, is it? The nice thing about volume is we've already done all the hard stuff. Surface area is a much harder one to work with, but we now can put it all together. All right, the volume of a cone with a base circumference of 20 pi inches and a height of 2 inches, more than twice the radius. All right, so I'm looking at this. What type of problem is it kind of like? It's a kind of a work backwards problem, right? Because literally they're talking about the base. Well, even though we normally don't draw the base, that's going to be your base, right? It's a circle. I know the circumference of it is 25 pi. What do I need to know in order to solve for volume, though? I have to know the radius, right? And my height. Make sure I forgot to get my squared there. So when I'm doing that, I really need to work backwards. I know 2 pi times the radius equals 25 pi. Well, guys, okay. Divide both sides by 2 pi. Oh no, your radius just turned into a fraction, which is what? 25 over what? 2. Not fun, but very doable. Now, let's look what it says here. Your height is what? All right, so this is algebra stuff that we have to know. What does more than mean? I'm going to add, right? So my height is 2 inches more than twice the radius. So I got to go 2r plus 2, right? Is the basic idea behind this? So I get 2 times the radius, which is 25 over 2, plus 2. What's the cool thing here? My height just became what? 27. All right, now I'm looking at this, and I see a fraction. So wouldn't it be wiser for me to write my formula like this? 1/3 times pi r squared times the height. Isn't that going to be easier for me to work with when I have fractions? Remember, you have permission to change between those. So I'm going to do that. So I'm going to go 1/3. I'm going to have my pi. Our radius is 25 over 2 squared. What's your height going to be, guys? 27? All right. Let your calculator do the whole work. Put it all in fraction mode if you need to. What's the one thing you're just going to bring along for your answer? The pi. So just don't put the pi in on your calculator and you'll be great. So what do we get here? 25 squared. Should be doing this on your calculators, guys. Practice helps. It should be pretty large. But think about it. You have a radius that's 12.5 and you have a height that's 27. It's pretty large. All right. So when you're working with this, guys, what did you get should be in the numerator of your fraction? It's a big number. Yeah, 5,625. What comes along, though? Pi. All right. What's the 2 has to be squared yet, guys. So it becomes what? Over 4, right? And then all we have to do is label it in cubic inches. That's fairly large. But they're talking about a fairly tall cone that we're working with. So it should be pretty big. Pull it under those. All right, what do you guys think so far? Doable? Not doable? Doable? All right, you guys do the next one because it's easy. Go for it. You guys do the next one. Let me know to help you out.
I gotta find the calculator right here.
Yeah. All right. How are you guys doing so far? What's an easy thing to do? All right, help me out, Xander. What did you say? One of the things that was really easy to confuse.
I thought the slant height was okay.
Yeah, it's very easy to confuse slant height and height because they both have the word height in it and it destroys everything, right? So the fact is, be very careful what you're looking for. It has to be the height. So basically from the vertex straight down. So be careful on that. So then you're going to end up using the Pythagorean Theorem. And by the way, it's just a multiple of an 8, 15, 17. But Pythagorean Theorem is a safe way of doing that if you didn't recognize that. So your height would end up being 30. So then it's just plug and chug it in. So write your formula. Where's the work supposed to be? Directly below. So your pi, your radius would be 16 squared. And then your height is going to end up being, what do we find it to be? 30 all over 3. All right. So if that's the case, isn't 16 squared 256? 30 divided by 3 is 10, so 10 times 256. Doesn't that give us 2,560 pi cubic centimeters? Volume's just large, people. It's just large, unless you're using small numbers. What do you guys think? Easy? All right, keep going. Do the next one. Do the next one.
Right? I mean, if you did it that way, just make sure that you did that there. Right?
All right, guys, what type of cone is that? Right or oblique? Oblique. Oh, guys, my favorite thing from the quiz, I gotta tell you, is someone called a pyramid obscure, and then one was obsolete. So like it didn't exist. I was like, I almost enjoyed grading quizzes because I thought that was funny. So we had an obscure ones, and then we also had, so we can't see it, we don't know what it is, and then we had like obsolete ones, so they don't exist anymore. Those were awesome. I mean, if that was you, I'm sorry, but I thought those were just awesome answers. They were wrong, but they were just awesome answers anyway. You know what I'm saying? It was entertaining if nothing else. All right. Now, so that's an oblique because remember it leans a little bit, but because of Cavalari's principle, we know the formula still works as long as I have the radius, as long as I have the height. So we get pi times our radius this time is going to be what, guys? What's your radius? 9, right? Because you're going to have to go 18 over 2, so that's going to give you 9. So we got 9 squared. Our height is 8 all over 3. Now, again, is this going to have a fraction as an answer? And the answer is no, because 3 can divide into your what? Into 9. So we know that's the case. What did you guys get for your total answer on this one? Yeah, so it's 216 what? Pi. Yep, cubic meters. Don't drop the pi, all right? This isn't bad, is it? No, and look at the very last example that we have here. It says find the length of the radius of a cone that has a volume of 21 pi cubic centimeters and a height 7 centimeters. All right, I want to know the length of the radius, so what do I have to do? Work backwards, because they gave us the volume. So here's volume. We have the height is 7, so we just write our formula down. So the volume is pi times the radius squared times the height over 3. The volume we know is 21 pi. We don't know the radius, that's what we're looking for, so it just stays r squared. Our height is 7 all over 3. Guys, what are you going to do first? Multiply by 3, right? So what do we get? We get 63 pi. Basically, isn't that the same thing as 7 pi times the radius squared? I can rewrite it, right? Doesn't matter what order I multiply it, as long as I multiply them together. So what am I going to divide both sides by? So I'm going to divide both sides by 7 pi now. And now I get 9 is equal to the radius squared. Because remember, divide pi by pi and make sure that's 1, guys. A few people are still hesitant on that. Well, what's the square root of 9? So it's going to be 3 what? Hello, radius. How do we label it? Centimeters. Got to be careful if it's linear or if it's area or if it's cubic. So if you have your squared, be very careful. What do you guys think? Not bad, is it? All right. So just a heads up. I won't see you again until Monday morning, unless you come and visit me for questions or something like that. So here's the things you need to remember for this. You have a test a week from today. We have one more section. That's it on Monday. And then we review on Tuesday, test on Wednesday. Everyone hear me on this? Okay. Which means a wise person would start the test review. Right? Just be wise on this. Your test review is a guided review. It's been online this whole unit. But on there, just think about like what the portfolio section of the review is going to be like, right? It's literally going to have you go through every lesson, like all the definitions, all the formulas. There's just tons of stuff that you guys have to know. So I would start doing it now, because don't tell me next week is not going to be busy for a lot of you. I'm pretty sure it is. Yeah, between sports and all that type of stuff, drama, all that good stuff. It's going to be there. So make sure that you get this done. All right. So work ahead so you have a life Tuesday night. Otherwise, you won't have much of a life. All right. Are we good?